In this video, I'm going to show how to take a set of data that looks like this, where we have quantity and price, and build a demand equation. The first thing that we want to make sure we understand is what this table of data is telling us. Since this is demand data, this is telling us that at a price of $556.08, then consumers will be willing to purchase 200 items at that price. You can see from the data as the price goes down, as the item gets less expensive, the number of people willing to purchase it at that price goes up. So each of these individual rows gives the relationship between quantity in demand and the price we can expect to sell the item if we sell this particular number of items. So the first thing we're going to do is just draw a picture of what this looks like and get a graph. So I'm going to take my mouse and click and drag from one corner of the table to the other, the opposite corner. And then I'm just going to go over here to the insert command and insert a chart. Now, Google Sheets, which is basically a spreadsheet application, is going to try to guess what kind of chart it thinks the data could best be represented by. So when I click this, it's going to give me a nice smooth line curve that represents this data. So you can see here that over here, P versus Q, so price is on the vertical axis and quantity, Q, is on the horizontal axis. So as the price goes up, the quantity gets lower. If I want to sell more items, if I want to sell 700 items, then the price per item has to go down from where it was when I was only selling 200 of these items. Now, our goal is to build a mathematical equation that models this set of data very well. And so even though Google Sheets has done a good job at guessing what the curve should look like, it's not in the right format yet. It chose to give us a line chart, but what we really want is what's called a scatter plot. So I'm going to click here under chart type, and I'm going to scroll down until I get almost to the bottom where I see a scatter plot, a real simple one like this. And what that will do when I select it is it will change the look of the graph. It still has that downward kind of downward sloping shape, but it's not connecting each of the dots with a smooth line. So that's our first step. Second step to finding the equation is to build what's called a trend line, which is basically the best fitting curve or line that goes through these points. To do that, we first start by clicking on any one of the points. So I'm just going to click on this one here. And you'll notice over here the options changed when I did that. And if I scroll down, I'm going to see down right over here the option to create a trend line. So I'm going to check that box. And what you'll see is that by default, it's going to give me a straight line, the best straight line that goes through that set of data. Now, that's a pretty good line. It fits that data pretty well. But unfortunately, it is not the kind of demand equation our project requires. We'll get to the quadratic version of the demand equation in just a moment, but I want to point out one more thing before we move on. You can see here that the type of trend line that the spreadsheet determines is linear. And then also, there's no label option that's chosen. There's none chosen for the labels. So I'm going to go ahead and from that drop-down menu, tell the spreadsheet to use the equation, meaning use the equation of a line to label that line. So when I click that, watch what happens. I actually get the actual equation of the line that was graphed for me. So this equation would be P is equal to negative 0.388 times the x variable, which is Q here. This is a generic variable, plus 646. So you can see that the y-intercept, or the vertical intercept, is 646, right? And the slope is 0.388. Now, the 646 is kind of hard to see because we can't see the 0, so we could actually change some of the options to see that, but that's not really important right now. Let's just focus on getting the right kind of equation. Then we'll massage the graph a little bit more. Again, this is the best fitting line, but we don't want a line for the demand function in the project. We want a quadratic. So up here in type, we don't want linear. Instead, we're going to pick another option. Now, because a quadratic is really just a polynomial with the highest power of 2, we sometimes say it's a degree 2 polynomial. A quadratic is a degree 2 polynomial. That's what I'm going to choose. I'm going to choose polynomial from the list. And now you can see that it actually fits the data slightly better. And now when I look at the equation, you can see that I have a variable x, which is really just quantity, that's being raised to the second power. So the equation here, which is in a form that is probably reversed from what you're used to seeing, has the constant term first, the x or the q term in the middle, and then the highest power of 2 term over here in the end. And normally we write those in reverse order. We also have something weird going on here with this capital E. This is Google Sheets' way of indicating scientific notation. So this is saying negative 3.4 times 10 to the power of negative 4. So if I were to take 3.4 and multiply it by 10 to the negative 4, that will require that I move the decimal place 4 spots because it's to the 4th power, but I'll have to move it to the left, right? If I'm raising something to 10 to the negative power, I'm making it smaller, as opposed to, let's say, raising it to 10 to the 4th power, where I'd be making it bigger. So because I'm raising 10 to the negative 4 power, I'm multiplying by something that reduces the size of this number. So what I'd have to do is I'd have to start with negative 3.4. Let's go ahead and type that in first. So negative 3.4 is the starting value, and then I'm going to move the decimal point 4 places because of this 4 to the left. So if I were to do that and move it 1, 2, 3, 4 places, I would instead have this, negative 0.00034. Right? So let's just double check that. If now I reverse that and move that decimal point 4 places to the right, I would go 1, 2, 3, 4 to get back to 3.4, and that's where I started. So really what I have here is negative 0.00034 times q to the second power, because q is the variable, minus 0.0816 times q plus 586. And so if you were to go and look at the equation in the project guide, you will notice that that's the precise equation that's given there for the class project. Now, if you want to make this graph look a little bit nicer, so you can, let's say, see the vertical axis over at 0, you can also do things like edit the chart in ways that are going to allow you to do that. So let's see if we can do that really quickly. Let's close the series and let's take a look at things like the chart and axes titles. You can see here it gives us the ability to change the text of the graph. So we could do something like this, demand equation, and that will update the title over here. Okay. So we can change something like that. We can look at the series, and we can change the color of things that we want the graph to look like. We can look at the legend, which is basically this down here, which is pretty much automated. We can look at the series, which is essentially more on how the graph particularly looks. And then we can also look at the horizontal and vertical axes. And so this is where it gets very easy to change the look and feel of this. You can see here the minimum value is kind of defaulted to match the data, but I could change that to a minimum horizontal value of 0, and let's say a maximum value of 1,000 for quantity. And when I do that, you can see now I can see the origin, and I can actually see where the demand function starts, and I can see a little bit beyond where the demand function ends in terms of the data that's given to me. If I want to go further, I could continue to experiment and look at a maximum of, let's say, 1,500. And there you can actually see where the demand curve crosses that horizontal q-axis. So you have a lot of ability to make this look the way you want to for your reports or for whatever other purposes you have. But that's an overview of how you would take a set of data and then turn it into a curve with an associated algebraic expression. So now it's time for you to do it with your own set of data given to you in the project, and you can now build your own demand equation.